Earlier in the semester, we solved right triangles, and we did that by using the Pythagorean theorem and using SOHCAHTOA, which is the ratio of the trig functions. You can only use those two devices when you have right triangles. We need to solve triangles that are not right. Sometimes these triangles are called oblique triangles. These triangles require the law of sines and the law of cosines. Pythagorean theorem and SOHCAHTOA only work in right triangles. Before we derive these laws of sine and cosine, we're going to review a little vocabulary. Specifically, the vocabulary of similar and congruent triangles. In order for triangles to be congruent, they have to have the same angles and the same sides. The corresponding angles and the corresponding sides have to be congruent. So if I take this triangle, or any triangle, and I clone it, then I have a congruent triangle. I can change the orientation of one of the triangles, but so long as I change the orientation of the other one in the same way, then one triangle will lay directly on top of the other one. These are congruent triangles. Similar triangles differ just a little bit. Similar triangles have corresponding angles that are congruent, but not necessarily corresponding sides. So here my angles are congruent. The angle in all three places are the same, but the sides are obviously not the same. We have different lengths, different size triangles. So these triangles here are similar, but they are definitely not congruent. These triangles over here are the same size, they have exactly the same angle measures, and they have exactly the same side measures. They can lie right on top of each other and match up nicely, so these triangles are congruent. Now you may notice that congruent triangles are similar to each other because they have corresponding angles that have the same measure. They just have that additional little thing about the corresponding sides being equal to each other. But not all similar triangles are congruent. Now that we've redefined what congruent triangles are, let's review the congruence axioms that you talked about in geometry. We can tell that two triangles are congruent to each other using the side angle side argument. If two sides and the included angle of one triangle are equal, respectively, to two sides and the included angle of a second triangle, then the triangles are congruent. Now, you can copy all of this, or you can just write this in your note. If you get side angle side, and you can tell by the way these are listed that the angle is included between the two sides because it's included between the sides in the way that we write this, then you can say that those triangles are congruent to each other. If you're given angle side angle where the side is included between the two angles, then you can say that those two triangles are congruent to each other. If you get two triangles that have the corresponding sides equal to each other, then those triangles are congruent as well. So these are the three congruence axioms that you need to be familiar with. You may want to pause here and write these down, or you can find this in the chapter contents of your book and print it off and put it in your notes.